Okay, so today we're talking about some more proofs, but we're gonna involve a lot more geometry. So I need to introduce you to some of our geometry properties. And I don't know, you might want to make flashcards or something because you do have to memorize these, but it's not as hard as it sounds because you're gonna be using them so much. Okay. Now, so what I just kind of did was I just kind of created like little mini proofs here to show you how where you'll see these properties. Okay. And the first one is the definition of a midpoint. And a midpoint is a point that divides segments into two equal parts. So if R is the midpoint, I know that QR equals RS, or in this case, segment QR is congruent to RS. So we're given R as the midpoint. So how do we know this? If we come across that, we would just say the definition of midpoint. Okay. And one thing I don't want you to do is worry about magic words. Like if you just wrote down it's a midpoint here, I would be fine with that. You just need to convince me that you know this because it comes from the fact that it's a midpoint. Definition of complementary angles are two angles that add up to 90. So if we say angle S and W are complementary, then our next line we could say measure of S plus the measure of W is 90. This would be the definition of complementary angles. Feel free to abbreviate too, because there's a lot of writing in this chapter. Supplementary angles, same thing, except 180. So if you're given this and you state this, you could say the definition of supplementary angles. A right angle tells you that an angle is 90 degrees. So if we say angle 2 is a right angle, we could conclude from that that the measure of angle 2 is a right angle. I'm just giving you examples of how you would see these reasons. An angle bisector. It divides an angle into two equal parts. So if we say BD bisects this whole angle, it would make angle 1 congruent to angle 2. So if we're given this, we can conclude this by the definition of angle bisector. Okay. Segment addition, we talked about this in chapter 1. If B is between A and C, then this plus this equals this. Okay. And angle addition says the same thing for angles. Okay. If S is in between, is on the inside, then PQS plus QSR or SQR would equal PQR. Okay. A couple other theorems. Vertical angles are congruent. Okay. We kind of mentioned that in chapter 1, but we didn't formally do anything with it. The linear pair postulate should not be plural. The linear pair postulate says if two angles form a linear pair, then they are supplementary, which remember means they add up to 180. Okay. The definition of congruence is a little weird. It's kind of just a technical thing. If two segments or angles are congruent, then their measures are equal. We won't see this too often, but we might once in a while. So if we said like segment AB is congruent to RT, then we could say the length of AB, remember that's what that means, equals the length of RT. This would be the definition of congruence. Or the other way around. Well, okay, here's with angles. Angle P is congruent to angle G. We say the measure of angle P equals the measure of angle G. We could say here also, remember, that's the symbol. You could use that symbol. Okay, so let's do a geometry proof or two. So we're given that JKL is a right angle. One thing that's a good idea is as soon as whatever you're given, mark your sketch that way. Okay, JKL is a right angle. That is given. So then we know, and guys, eventually you will need to fill these in yourself. So like, don't just read them, think about how we know them. Then we know JKL is 90. That is because we know what a right angle is. Okay. Okay, 3. JKL is angle 1 plus angle 2. Now, how do we know that? We don't know that from any of this stuff yet, but we also have a picture. And in the picture, angle 1 plus angle 2 adds up to JKL. That is angle addition. Okay, now think about how we get from 3 to 4. Or from I shouldn't just say from 3 to 4, but from all of this to 4. Notice what we did. We replaced JKL with 90 degrees. We knew that from line 2, so we substituted a value for JKL, and that is called substitution, which we saw in the first lesson. Then, angle 1 and 2 are complementary angles. Well, that's exactly what complementary means. So that's the definition of complementary angles. Okay, second example. Okay, OB bisects AOC. Okay, that is given. Now, let's think about what that means. What bisect means is it makes these two equal. So, how do we know angle 1 is congruent to angle 2? That's because we know what bisecting means. So that's the definition of bisect. Now line 3, angle 2 is congruent to angle 3. Well, neither of those lead there because they haven't even mentioned angle 3, but our picture, what do you know about angle 2 and angle 3? Those are vertical angles, okay? And that was, now here's the thing. That was called the vertical angle theorem. You can either like refer to it by the name of the theorem, or you could just write out what the theorem says. I kind of like to just write out what the theorem says, because then I don't need to worry about names. So you could just write vertical angles are congruent. Now, how do we get to 4? Okay. We look at the previous two lines. We knew 1 was congruent to 2, and 2 is congruent to 3. So then we can get 1 congruent to 3. That is called the transitive property, which we saw in the first lesson. That's the one where we have the train. Okay, if you put substitution there, that would also be okay, because we just change angle 2 to angle 1. So like, if it's transitive, substitution would always work, but not the other way around. Like, you can't always call substitution transitive. Like if we look back at this one up here, where we replaced JKL with 90, that really, like, we didn't really have the train there. We kind of did. It was in backwards order. It wouldn't be like, I don't get huffy about it, but you probably shouldn't do that. So that is that.